All right, so the first page, very, very first page. All right, so let's take a look on Desmos, what this graph actually looks like. See if we know it's going to be parabola, but we're going to be able to do this two different ways. So I got 3x squared plus 5x minus 4. All right, and home. All right, so it's a parabola. Agree? Now, let's make sure we have an understanding of, we know that this point here and this point here are both important, but how do you make those fractions? And the answer is you can't. Okay? You can't make those fractions because these, usually it's going to be very unlikely that I'm going to give you a fraction that would go out 6, 7, 8 decimal places that I want you to make that. So these are called irrational roots. And an irrational root does indeed cross the x-axis, but it crosses at a radical type of answer. Okay? So technically, those are the two answers, but they're truly not the exact answer. So let's figure out how we can get there. So is there space somewhere on the side of your paper that you can see how this can be done? If not, figure out some place that you can write it. So I have 3x squared plus 5x minus 4. Okay. Quadratic formula, we're making fun of it because it was just a trick. Those are all things that I was telling you about. Like, you've learned a whole bunch of tricks about math, and you're like, oh, I'm just going to plug in and go for it. Okay? Unfortunately, you don't have really the understanding of doing it. So what I want us to start realizing is the tougher mode, but it's used globally. It's a great thought process. And once you get through to the understanding of how to make it work, it's not really hard. But I would like us to complete the square. Okay? So these asked us just to factor each. This one is not going to factor. All right. So first thing I'm going to do is I'm going to set it equal to 0. You still with me? No problem there, right? If we complete the square, I don't want to have in front of my x squared, I don't want anything other than 1. So if I do this, this will reduce down, and this gives me x squared plus 5x over 3 minus 4 over 3 equals 0. Okay, now, friends, I know that fractions are the scariest part of any type of arithmetic. If you trust me, I can get you through dealing with fractions on completing the square in a very simple way. Okay, so let me go to this. What did I just do from one to the next? Yeah, I added 4/3 to both sides. That's all I did. So I'll put a little note over here. I just said add 4/3 to both. And I'm going to say keep the space. Does that make sense? So let me explain what keep the space means. I added 4/3 over here. That way this went away. I left the space that 4/3 had originally lived. Does that make sense? All right, so completing the square. Again, I wish we never even used the quadratic formula. I wish you'd never seen it, because honestly, completing the square will work on every problem. It's a beautiful method. The first couple times you see it, it's like, oh my gosh, no way. And then all of a sudden it's like, this isn't impossible. All right. So what we are doing is something called complete the square. This is not hard, trust me. The reason we make it hard is we have ingrained in our brains fractions are not easy. Okay, ready? This is going to be the easiest thing in the world. If I double a denominator, that means that's the bottom number. Still with me? If I double it, that just means I multiply by 2. If I multiply that denominator right there by 2, I get 5 over what? Okay. I'm just going to pause there for a minute. We're not done with the problem, but that's what's going to go there. So I'm going to put a little disclaimer here. Double bottom to get to there. Okay, do you see it? Now, we're not done with that yet. Okay, so in the whole indoctrination of us teaching you FOIL back in the day, first, outer, inner, last, right? If I went 5 over 6 times 5 over 6, which means I'm squaring 5 over 6. So 5 times 5 is 25. 6 times 6 is 36. If I add, notice I'm adding it here, so I have to add it to the right side as well. Okay, now what I want you to understand is this right here is this FOILed out. But I haven't really done anything real hard with fractions at this point. Okay. So what I'm doing is I'm trying to figure out what I would plug in to my binomials to make it work. Okay. Again, if you use the quadratic formula, you might get, 3 plus or minus square root 6 all over 7 or something like that. If you do complete the square, it's going to come out a lot nicer. So I'm going to multiply this by 12 and by 12 because we have to get common denominators. And so that's 3, what's that, 73? Equals 73 over 36. Okay, now we just got nasty with fractions, but I haven't heard anybody really gasp at it too much. Are you following everything that I did? I just got a common denominator. Yes, you could have done the butterfly method if you knew that. Okay, so I'm going to come down the screen. So I have x plus 5 over 6, quantity squared, equals 73 over 36. I want to solve for x. Root, don't forget the plus minus. That gives you x plus 5 over 6 equals plus or minus root 73. And the square root of 36 is 6. And then subtract 5 over 6. Okay. That's the answer. But they didn't ask us for the answer, did they? They asked us for what 2 binomials do we multiply together to get there, right? Okay. And again, trust me, I'm not going to just show one method of this and say, oh, look, you all know how to complete the square. I'm just showing you the math that's behind it. Quadratic formula is completing the square if you have ax squared plus bx plus c, doing the same exact math, but it just all takes place and goes through. So I'm going to take this answer and I'm going to do this. What did I do to get that? Yeah, multiply by 6. And then I'm going to go this. Okay. So I'll just subtract it. So then this is going to become this. I'm making up numbers just to confuse the heck out of everybody. There's one solution. Here's my second solution. Okay. That is ugly. But that is the binomials that you would multiply together to get our original equation, which was 3x squared plus 5x minus 4. Okay? Can we play with this a little bit? Can I move off? Is there anything else on that screen that you want me to take a look at? Okay. All right. want to give you a sheet of paper, and we're going to walk step by step, and use this, somehow adhere it inside your books on completing the square. And we're going to try a problem just like what we just did. We'll make sure that we can see it. Okay? It's not going to hurt you to try it. It's going to actually change a little bit of your thought process, which is okay. Single sheet of paper. All right, ready? Nope. You're just going to hide this in your book, and that way it'll be to refer back to. Now I just have to come up with one that doesn't factor. Let's go with Is that going to factor? Dang it. How can I'll make that minus 10. All right. So you're just going to call this complete the square. Stop me as soon as it stops making sense. Equal 0. Good so far? Agree? 2 divided by 2 is 1. 5 divided by 2 is 5 over 2. Negative 10 over 2 is negative 5. 0 divided by 2 is 0. All with me? Yay or nay? Okay. Okay, you're going to make parentheses. And the x term is going to be squared, not the x squared, the x term. Okay, so the first thing is this x comes here, this positive sign comes here. If it's a minus sign, it'd be a minus sign right there. Good so far? No. And I have to do half of x term. Goes in parentheses. What's half of 5 over 4 or 5 over 2? 5 over 4. If I square 5 over 4, I get 5 times 5, which is 25. 4 times 4, which is 16. Be sure to add it to both sides. Okay, so the big thing that comes with this is if I had x plus 5 over 4 in parentheses times x plus 5 over 4 in parentheses, and I did FOIL, you get x times x, which is x squared, x times 5 fourths, which is 5 fourths x, plus 5 fourths x, which becomes 10 fourths, which will reduce. And 5 fourths times 5 fourths is 25 sixteenths. So what do I have to do with this 5 plus 25 over 16? Square. Not square yet. squared 5/4 to get 25 over 16. What math? Right around 5th or 6th grade where you stop paying attention to math. And you stop paying attention to math because you're a fraction. Agree? Makes you normal. Okay, so I want to get a common denominator. So if I have a 5 and I'm adding it to 25/16, what does my common denominator have to be? 16. So I'll put that over 1, multiply that by 16, that by 16. So that's going to give me 80 over 16 plus 25 over 16, which is 105 over 16. Don't fear the fractions. I can get you through them. What's the last step? Almost the last step. What should I do to both sides to start getting x all by itself? Square root. Root. Don't forget the plus minus. Square root of 16 is 4. Subtract 5 over 4. Which leads us to this answer. But we still want to figure out the binomials to multiply together. So let's see if you can catch on. Marley, I promise this class is easy. You're like, we were just doing sine x, and I said, I'm out of here. And then you get in here, you're completing the square. Basically the story. Or was it more of a text? Oh my gosh, you should have stirrup. Uh-huh. Uh-huh. It's called completing the square. What I do from here to here? Yeah, multiply each side by 4. And so basically your answer comes out to this. Because I started sniffing glue. So it's 104, isn't it? It was supposed to be 104? It is. Boy, I'll tell you. This might have been where I was having problems in math. I'd start making up numbers and throwing stuff in there. All right, so my binomials to multiply together, which actually aren't binomials, they're called conjugate pairs, is this. You know what's nice about this class, though, Marley? Every test and quiz, compare, share, and revise. Y'all working on it together. But you can't ask me how to do it. Okay. Guess what I don't have problems with during tests and quizzes in this class? No. Absences. Oh. Nobody ditches the class during test and quiz day. Yeah. All right. So that is like hard algebra on steroids. Okay? But it's the term that they've used, and they use it lightly with y'all, is the conjugate pair. The nice thing about a conjugate pair is a conjugate pair means that your equations are both pretty much identical with one sign different. 4x plus 5 plus root 105, 4x plus 5 minus root 105. These are called conjugate pairs. Okay? Conjugate pairs, you were only told that show up when you did like the square root. If you had x squared equals 16, square root both sides, where you get plus or minus 4. That's a conjugate pair. Conjugate pairs also take place if you have an answer that is a irrational answer. One of the binomials are conjugate pairs of each other. If you have if you had something called an imaginary answer, you're going to have conjugate pairs. We're not really dealing with imaginary right there. But let me flip to the next page. That's tough. Let me flip this page over, see where we're at. Ah, these are all the synthetic division ones, right? All right, synthetically dividing. How do we do with these? Do what? Pretty good. That's the first time you ever looked at it, kid. All right. So, which one you want to see? Any or all? All? Okay. Starting out with number 16. You with me so far? I'm going to graph number 16. When I graph it, because we use Desmos, this does it so nicely for you. You can use it either on your phone or on a computer or tablet. 3x minus 15. All right. So the most important part with this is, can I find where it crosses the x-axis? Okay? So this equation, x to the third, has 3 solutions to it. In this case, it's going to have one real solution. Real is referring to something called the number system, the real numbers. If it's a real number, it could be rational or irrational, meaning it could be something that could be a whole number or a fraction or a decimal that never repeats. That's irrational. But it crosses the x-axis. So right there is the only real solution. The little wave down below, a miracle has taken place, and it is creating something that is in the imaginary number system. So right now, our xy axis is real number system for the x direction, real number system for the y direction. So you have real by real. So real by real means where it crosses the x-axis will be an actual answer. So I'm going to use that 5, and we're going to figure out the rest of the answers. So we're good with that 5. And my equation was, get this out of my way, x to the third, I'm getting all sloppy, minus 5x squared plus 3x minus 15. All right. Who in here, other than in this past week, has used synthetic division before? Okay, so you've seen it. So like when I'm not saying you're perfect at it, but you've seen it. Synthetic division is kind of like the miracle occurs. So you have to make sure you list all of your values and signs, and you make sure that you don't have any gaps. So I have x to the third to x to the second to x to the first to x to the 0, so that works. And so if I synthetically divide this, very first number comes down, and you multiply. 1 times 5 is 5. Add straight down, I get 0. Agree? 0 times 5 is 0. Add straight down, 3 plus 0 is 3. 3 times 5 is 15, which gives me a 0 there. So that 0 means that the point 5, 0 is on our graph. Okay? It is a real solution. The R with the double line on it means for the real number system. And again, friends, kid you not, real number is the name of the number system. They were mean when they started doing number systems like this. Because you have real, you have imaginary, you have complex, you have imaginary. I mean, it becomes like a thing. It's like, well, how can you graph something that's not in the real number system? Well, it's complex. What do you mean it's complex? Well, it's imaginary. What? Not like it's not real? No, it's not real. It's imaginary. What do you mean? Like it's fake? No, not fake. It's not real. They name the number systems the most awkward names in the world. Okay? So if you had this type of thing, this would have started out as x to the third. Agree? So this right here would actually be x to the second plus 3 equals 0. Where is the x term? It's gone. It's 0x. I mean, technically, I could have had this. And then I just eliminate it. So then, solve this. All right. So I know some of you might understand where some things came from, and others you're going, start making up letters again. All right. Are we clear with this so far? Like to this point? Anybody stuck? Okay. So then this, realizing this was x to the third, this becomes x to the second because we divided, we broke down a dimension. X squared equals 0, x plus 3, which is the same thing as x squared plus 3 equals 0. Subtract 3 from both sides, take the square root of both sides. Root, I get plus minus, square root negative 3. So I get, because I have a square root of a negative, it means I have an imaginary root in the answer. This being imaginary is part of the complex number system, okay? Which means it's not going to cross the x-axis. The reason it's not going to cross the x-axis is your x-axis is real number system to real number system. We didn't change one of them to imaginary number system, okay? So that's kind of a big thing. It's weird to think about, like, why would I have two number systems together? It's the xy axis. Yeah, it's the real versus the real. It's like in chemistry, if you were doing one of your plots, you're sitting there like, you add a whole bunch of some salt to the water to figure out the boiling point of water was, and you add some more, and you add some more, and add some more. And on one axis, you have the amount of salt. The other one, you have the temperature it boils at. Okay, same idea. Those real to real numbers, but you're changing them from one being real numbers to the amount of salt to the other one being temperature in Fahrenheit or Celsius. Okay, so that's that first problem. And it says factor each of the following using synthetic division. Okay, I can't factor any further on this problem other than knowing this. I had my original 5. So I had x equals 5, which leads me to this. And then I had this answer. And so if I go and try and put this back into a binomial, which is going to be this, which is then going to become this. And here's the factored form of it. This and both of those. Imaginary numbers come in conjugate pairs. Conjugate pairs meaning that they look like the same two binomials, but they have separate signs. So that's how you factor number 16. It's like, wait, stir up. This is kind of weird math. Can I move on? So 17, 18, and 19 are going to be done the exact same way. Is there any of those that's going to stick out? I mean, I know you say all of them, but they're all really going to be done the same way. I'm going to use Desmos to figure out where it crosses the x-axis. Then I use synthetic division for that one. Did any one of those others, did any of them come out to, on Desmos, all three cross the x-axis? They did? Which ones? Okay. Let's just take a look at the rest. All right. So going back to Desmos. So plus 3x squared minus 6x minus 15. Okay.
Minus 8.
Oh, minus 8. Thank you. See, again, Stirp's making up stuff as we go along. All right, those are my two solutions. So -4 goes with the binomial x plus 4. Agree? -1 goes with the binomial x plus 1. +2 goes with the binomial x minus 2. So this factored out would be x minus 2 forgot what they were. So x plus 4, x plus 1. There you go. That's that factored out. So you can literally just plug in to Desmos. It finds you the real solutions because they cross the x-axis. So minus 6x, this is the next one, squared plus 11x minus 6. So just tap on. So x minus 1, x minus 2, x minus 3 is number 18 factored out. And last one. Two x raised to the third. Whoops. Thank you. Plus 5x squared. Plus x minus 2. Point 0.5, same thing as 1/2, right? So this one yields me x plus 2. This yields me x plus 1. This yields me 2x minus 1. Agree? Sweet. We can turn the page now. You guys all get that done? Well, that'll be your first assignment at Toronto book. Yeah. You don't have to pull it out of your book. Spiral. Keep it all nice and neat. All right. This one's going to be a little bit nicer breath of fresh air for you. Okay. Please solve. Cool. We can do this. All right. Desmos is our best friend. If you take a look at the very first problem, I'll show you how to do it. Ready? Very first problem. X, is that x squared? Minus 3x. Okay, I'm going to graph that first. Y equals x squared minus 3x. And then I'm going to graph my other equation as y equals 10. So I graph the two sides. Okay. So I have a left side, I have a right side. The left side I'm going to graph as one equation. The right side I'm going to graph as the other. When I graph just a number, it becomes a horizontal line, taking back to Algebra 1, which you didn't cover enough in Algebra 1. Sorry for those of you who had me in Algebra 1, I didn't cover it enough. So the answers I'm looking for, I'm not looking for the point, I'm looking for the x value. So my answers are -2 and 5. I'm not using the entire point, I'm just using the x value. Okay? So the reason why I'm not using the y value is when I look back at this problem, it's not y equals. I'm using Desmos to cheat it a little bit. So you can do the same thing on number 2, 3, 4, 5 is just algebra 1. So I would say, why don't you do these for tomorrow? Using that exact method I just showed on Desmos. Am I going slower than Calc 1? No. Just a little. I got a little too much extensive on the irrational roots. Okay. I'm trying to teach you guys something, but I know you've seen it all, so I'm like, I like your purple shoes, by the way. At least I think they're purple. I'm losing cones. Seriously, I'm going colorblind the older I get. Yeah, so when I walk downstairs, my wife's like, "You wearing that?" I'm like, "No, just trying something."